Solved problems. First problem. We derive there exists z r0 zy from there exists x r0 xy. Note that the only difference between the hypothesis and the conclusion is the bound variable. Since the assumption there exists x r0 xy is existential, starts with an existential quantifier, we try to use the elimination rule of existential quantifier. The idea of the elimination rule is that since we assume that there is an x such that r0 xy, we in a sense pick an x because some such x exists. And we assume that it satisfies r0 xy. Then we set up the stage for the application of the existential quantifier elimination rule. Somehow we have to derive there exists z r0 zy from the assumption r0 xy, or from the original assumption there exists x r0 xy. But this is actually very easy because from r0 xy we can immediately conclude there exists z r0 zy. And we have to check that certain conditions are satisfied. X should not occur free in the conclusion. There exists z r0 zy. Well, there is no free occurrence of x there. And x should be free for z in r0 zy, which it certainly is. So we are done. We want to derive there exists y, there exists x, left parenthesis r0 xy or r1 yz, right parenthesis, from for all x, for all y, left parenthesis r0 xy or r1 yz, right parenthesis. Our assumption is of a universal form. It starts with two universal quantifiers. And our goal is an existential one. It starts with two existential quantifiers. In a sense, we have to move from the universal knowledge of x and y to the existential knowledge of y and x. This shouldn't be too difficult. First we eliminate the first universal quantifier, then the second. So now we have r0 xy or r1 yz. Okay, so here x and y are the witnesses that we need for the existential quantifiers. So we can start introducing existential quantifiers. First we introduce there exists x, and then we introduce there exists y. But we have to make sure that certain criteria are met. So when we eliminated the universal quantifier for all x, we substituted x for x. It's like not substituting at all. X is always free for x, so that was fine. Also the next universal quantifier elimination was fine because we substituted y for y, which is like no substitution at all. Y is always free for y. So these were surely permissible. For the introduction of the existential quantifier, we just need to make the same observations, that x is free for x and y is free for y. So we are done. And here is the deduction. Here is the next one. We want to prove by natural deduction the following inference. If someone is a friend of everybody, then everybody has a friend. Well, this sounds plausible enough, but the trick is we have to prove this by natural deduction. Let's think, why does this sound so plausible? Take this someone x and assume it is indeed a friend of everybody. So why is it that everybody has a friend? Let's take somebody y and look for a friend for y. By assumption x is a friend of y, so y has a friend, namely x. This is the way the inference should go. In fact, we can write this problem in the following form. We assume there exists x such that for all y r0 xy, and we want to conclude for all y there exists x such that r0 xy. So r0 xy is here. The predicate x is a friend of y. Let's now draw the deduction. We have the assumption there exists x such that for all y r0 xy, and we want to conclude for all y there exists x r0 xy. If we use the existential quantifier elimination rule, then we can make a temporary assumption in which we pick an x. And we have the temporary assumption for all y r0 xy. And from that we should try to derive the blue formula for all y there exists x r0 xy. This is how the existential quantifier elimination rule works. So now we move to the question how to derive for all y there exists x r0 xy when we know for all y r0 xy. Okay, we can first observe that if we can derive there exists x r0 xy, then hopefully we can take advantage of the universal quantifier introduction rule and conclude for all y there exists x r0 xy. This seems promising since y is not free in the assumption for all y r0 xy. But how to get to this formula there exists x r0 xy? Well, all we need is r0 xy, because then we can get with existential quantifier introduction there exists x r0 xy, because x is always free for x. Now the rest is easy, because for all y r0 xy we can readily get r0 xy with universal quantifier elimination rule. Again, observing y is free for y. So in this deduction we once used the universal quantifier introduction rule, and we can now again observe that when we used it, the variable y did not occur free in any of the assumptions. The only assumption that is used in the derivation of there exists x r0 xy is the temporary assumption for all y r0 xy, but y is not free there. It is just the contrary. This formula even starts with for all y. So surely y is not free there. So the deduction is ready.